This is the fifth lesson of intermediate first year. So stoichiometry. In this lesson, we are going to discussion about atomic weights, molecular weights, equivalent weights, and mole concept, oxidation number, balance chemical equation. Majorly, we are going to discussion in this lesson these terms. So before going to that one, just you have to basic concept you have to read here. In this paper mainly temperature conversion is there. There are three common scales to measure the temperature: centigrade, Fahrenheit, Kelvin, or another one Reimer is there. The temperature scales are calculated to each other by the following equation. So F is equal to 9 by 5 centigrade plus 32. For example, question given: how many Fahrenheit of 37 degrees centigrade? So that is 98.6. That is the normal body temperature of human being. How many Fahrenheit of minus 40 degrees centigrade? So the scale equal to 40 degrees at minus and plus is equal to same. How many seconds in 2 days? So you have to calculate similar way. We move on third paper. In this paper only we are going to discussion of atomic mass. So 1 to 30 elements given here. So next molecular weight of the molecular weight or molar mass, how to find out in this paper given. We move on next paper, that is the here some compounds given: HCl, H2SO4, phosphoric acid, oxalic acid, acetic acid, formic acid, nitric acid, oxalic acid, sodium hydroxide, potassium hydroxide, calcium hydroxide, aluminum hydroxide, beryllium hydroxide, sodium chloride, magnesium chloride, calcium chloride, aluminum chloride, beryllium chloride, carbon dioxide, sulfur dioxide, sulfur trioxide. So those respective compounds, how to calculation part here given. So just you have to observe how to calculate. We move on next paper. Here nitrogen dioxide given, nitrous oxide, sodium carbonate, sodium bicarbonate, urea, glucose given, sucrose given, ferrous sulfate, potassium permanganate, calcium carbonate, methane, water, zinc oxide, oleum, phosphoric acid. So Marshall acid is given. These compounds given, calculation part also are given. Next we move on next paper. Equivalent weights. How to find out the equivalent weight here given. In the case of acids, the value of direction of unimolecular weight of the acid by basicity. So equivalent weight of acids given, molecular weight of by basicity. Basicity, how to find out the number of releasing of hydrogen atoms from the given molecule. HCl given here, basicity is 1, sulfuric acid 2, phosphoric acid 3, acetic acid 1, formic acid 1. So equivalent weight like this govern molecular weight of the compound by the basicity. So here equivalent weight of the molecular weight by H2SO4, molecular weight of phosphoric acid, molecular weight of acetic acid, molecular weight of formic acid given respective acids here. We move on next, equivalent weight of bases. So equivalent molecular weight of the compound by acidity. Acidity nothing but the releasing of the given compound releasing the OH minus ions. ఇచ్చినటువంటి కాంపౌండ్లో OH minus ions సంఖ్యను molecular weight of the, for example you have to observe here, equivalent weight of NaOH, molecular weight of the NaOH by acidity of given base. So 40 by 1, that is the equivalent weight, and molecular weight is the same of the NaOH, similar to that one. Equivalent weight of calcium hydroxide, aluminum hydroxide, barium hydroxide. Next one, equivalent weights of salts, molecular weight salt by total number of positive or negative ions. We will like this calculate molecular weight of the salts given compound by the charge. How to releasing the charge, we observe here. Equivalent element way. So you have to remember equivalent element equal to atomic weight of the element by valency. How to find out the valency? You have to remember group number equal to valency. Equivalent weight of sodium equal to atomic weight of the valency one is the like that carbon you have to find out, nitrogen you have to find out, oxygen you have to find out, fluorine you have to find out. Percentage of the element you have to find out. The weight of the element present 100 grams of sample of the compound is calculated by the percentage of element. Percentage of the element equal to atomic weight of element by molecular weight of the compound into 100. So for example, how much percentage weight of carbon in CH4? Percentage of element equal to atomic weight of the element by molecular weight of the compound. Atomic weight of the element is the 12. Compound weight is the 16 into 100. So 75% of carbon present in the CH4. So similar manner you have to calculate given this paper. How much percentage of weight in H2O? How much percentage of weight of oxygen in H2O? The percentage of element equal to atomic weight of the element by molecular weight of the compound into 100. 16 by 18 into 100. 88.8% oxygen present in the given molecule water. So next we are going to take the empirical formula. The simplest formula showing the relative number of 1 mole of compound is called empirical formula. So how to find out the empirical formula? Given this step by step 1, step 2, step 3, step 4 is given, step 5 also. Find the empirical formula weight. So molecular formula how to find out N equal to empirical formula weight. How to find out the N equal to molecular weight by the empirical formula weight. So here one question given. A carbon compound contain 12.8% of carbon, 21% of hydrogen, 85.1% of bromine. So the molecular weight of the compound is 181.9. Calculate the molecular formula. So step by step given here. So step 1 what is the what is the given empirical formula given CH2Br. The empirical formula weight find out the molecular formula N into empirical formula. That purpose we are going to find out the N value molecular weight compound. So later we will final formula how to write down like this. We move on next paper. So similar example given in this paper, similar model questions. Here one question given, same here. Second formula, second question given. Here second question also completed, that is the potassium dichromate given compound. Method expression of concentrations. So expression of concentration, the solutions are amount of the substance percentage in a given value of the solution can be expressed by the following method. Solution equal to solute plus solvent. So expression methods here given. Concentration method, molarity, normality, mole fraction. Molarity, how to take the molarity, how to find out the molarity. The number of moles of solute in a 1 liter of the solution called equal to molarity. It is denoted by the N. M equal to N by V. So in liters. N how to find out number of moles of solute. Moles how to find weight by molecular weight you have to find out. Weight by molecular weight you have to find out. Like this given weight by molecular weight. So calculate the molarity of NaOH in a solution prepared by the dissolve 4 grams of enough water from 250 ml of the solution. So M by W by GMW 100 ml. So given like this solution, we will get the answer. Same model, how to find out second question. Calculate the molarity of NaOH solution prepared by the dissolving 4 grams of enough water in 500 ml. Same similar model. So next move on next question. Same similar, just you have to observe and how to calculation part you have to say. Next, fourth question. Calculate the molarity given compound. So similarly, how to find out? Here, calculate the mass of the sodium carbonate to prepare the 250 ml. Mass find out. Next one you have to see here different concept, that is the normality. Normality called weight, but gram equivalent weight you have to find out. So units equal to gram equivalent weight by the liters. Calculate the normality of NaOH solution prepared by the dissolving containing the 4 grams of NaOH to 50 ml of the solution. Weight of the 4 gram, molecular weight of 40 gram, equivalent weight here, not GEW find out, GMW not here. Gram equivalent weight, how to find out? Previous manner we find out, that is the calculate the mass of the sodium carbonate to 250 ml of 0. Normal solution. Normality of this compound, GMW of GEW of this compound. Sodium carbonate, this is salt, is the charge is the 2, so 51, 53 GEW, not GMW here. That point you have to remember here. Next question, move on, that is the solution containing 6.100 grams of solution. Similar manner you have to find out. Next one is the molality. So the number of moles of solute in 1 kg of solvent. It is indicated by small m. Weight by GMW. 1000 by W in grams. Solvent weight here given. Solvent weight in moles per kg. Calculate the molality of a solution containing 60 grams of sucrose in 100 grams of H2O. So formula molality equal to weight by GMW 100 by solvent weight. Weight of the solute 60 grams. GMW of oxalic sucrose 180. This is the glucose, not sucrose. C6H12 was a glucose formula. Weight of this solvent is 100 grams. Molarity equal to, find out, that is the next mole fraction here given. Next year also, second year lesson also, this is the important mole concept, just definition here. We will see problems on mole fraction in solution lesson in second year. Number of components by the total number of moles. So Na by Na plus Nb. So next one, oxidation reduction concept. What is the definition of oxidation? So loss of electrons is called oxidation. Gain of electrons is called reduction. Increasing the positive valency, decreasing the positive valency, reduction. Adding of oxygens, adding of hydrogen, removal of hydrogen, removal of oxygen. In this manner, in this lesson, major important. Second one, increasing the positive valency is the important concept. So when we are going to simply oxidation number find out, easily we can find out the is it a oxidation or reduction, easily find out. So based on these definitions you have to remember. In this lesson mainly second definition you have to important. Increasing the positive valency you have to remember, given the equation and the respective elements we have to remember. So next one, oxidation number. It denotes the oxidation states of an element in a compound is called oxidation number. So calculation number rules to find out here. Oxidation number can atom by the atomic molecules in elementary states is 0. ఏదైనా మూలకం ఒకటే ఉంటే దాని యొక్క ఆక్సిడేషన్ స్టేట్స్ 0 అని. ఇన్ ఫస్ట్ ఏ గ్రూప్ ఎలిమెంట్స్ ఆక్సిడేషన్ నెంబర్ ఫస్ట్ ఏ గ్రూప్ ఎలిమెంట్స్ ఆక్సిడేషన్ నెంబర్ ప్లస్ ఏ, సెకండ్ ఏ గ్రూప్ ప్లస్ 2, థర్డ్ ఏ గ్రూప్ ప్లస్ 3. So like that you have to remember. Oxidation number of oxygen its compounds generally -2, -1 peroxides, minus of superoxides. Oxidation number of fluorine, chlorine, bromine, cyanide equal to -1. So finally the sum of the oxidation number of all atoms in a compound must be 0. Final 0 JL. So given one by one question given. Find the oxidation number of Mn in KMnO4. KMnO4 manganese కనుక్కోవాలా. సో ఏ విధంగా ఇచ్చానని చూడండి. లెట్స్ Mn oxidation states is X like this given. K potassium first A group +1 కనుక్కోవాల్సింది manganese X అనుకోవాలా. సో ఆక్సిజన్ -2 కాబట్టి -2 × 4 = 0. Finally simplification manganese oxidation number is the 7. Similar manner some compounds here find out. Sulfur in Carous acid, this is the oxidation number of chromium in CrO5. This is the special cases you have to remember. Find the oxidation number of Mn in MnO2 minus, manganate MnO4 minus. Next one, sulfur trioxide you have to give in. Find the oxidation number of sulfur in sulfate ion. Find the oxidation number of P in phosphate ion. Next, oxidation number of chromium in Cr2O7-2 ion. Next, to find the oxidation number of NO3. Find the oxidation number of sulfur dioxide. Find the oxidation number of oxalate ion. Find the oxidation number of N in NO2. Find the oxidation number of sulfur in sodium bisulfate.
లోపలికి బ్యాగ్ ఇట్లా రాసుకుంటావా లోపలికి దాని ఎట్లా దమ్మ వస్తావా వస్తావా చెప్పు తెగిపోతుంది అది వస్తావా వస్తావా అనుకుంటాను తెగిపోతుంది
Next we are going to see balance equation. Some rules are given, just to carefully observe and read carefully. Some rules are given, carefully read this one, this paper. Move on, next paper. First question given. First of all, before going to balance equation, in which medium, that is the important. Next one is the oxidation or reduction. Basic point you have to remember, like this given. Finally we addition of first equation, second equation, that is the balance equation.
ఇప్పుడు ఏం చేయాలి నేను ఏం చేయాలి చెప్పు అందులో ఎవరు అవుతారు చెప్పు నాకు ఇప్పుడు ఏం చెప్పు
Stoichiometry calculations, weight volume calculations. If 1 mole of any gas at STP conditions occur, occupied 22.4 liters volume. Here we have two types of redox reactions: chemical combination, decomposition, so displacement, disproportionation,